Alright guys, so video 3 for lesson 3.3. We're going to start out with example 3 here, and now we're doing the opposite of what we did in example 1 and 2, where we expanded. Alright, so in example 3 though, we're going to condense. So, we have log of 3x minus log of 4y. So now we're doing the opposite. Before we said, remember, when they're being multiplied, we expanded them by addition. So now if they're being added, we're going to put them together by multiplication. If they were being divided, we expanded them with subtraction, and now if they're subtracted, we're going to put it back together by division. So we can see this what is applying here because they're being subtracted. And we know that when you divide, you subtract, which means we need to put these together back using division. So the log is only going to be written one time because we're shortening it. We only write it once, and then it's of whatever is first divided by what is second. And if I could reduce that, then I would, but I can't, so there's my answer. Moving right along, on B, it says 2 times the natural log of x plus 1/2 times the natural log of x squared plus 1, with x squared plus 1 being in parentheses. Alright, so it's also the opposite of what we did before. You notice before we always we separated it and everything, and then we dealt with the exponents. Well, now we got to deal with the numbers in front, and then we put them back together. So we can see here that I have a 2 in front of my first log, so it's going to bungee or move back over to be an exponent. So it's going to become natural log of x squared. Plus, the same thing with this 1/2, it's going to move to become its exponent. So the natural log of x squared plus 1 to the 1/2. Now, we don't like fractional exponents though. And we know that before what gave us the 1/2, we meant 1/2 raised to the 1/2, means the same thing as the square root. So we have the natural log of x squared plus the natural log of the square root of x squared plus 1. And now that we've dealt with the numbers in front, the constants in front, and we've dealt with the, the coefficients in front, and we've dealt with the exponents, now we can actually put these together. And because they're being added, we can put them together with multiplication. So we get the natural log, remember you're only going to write the log once because we're condensing it, of the first times the second. And it's all condensed up. It's down to one log, can't work anything out, so there is our solution. Alright, so moving on, let's look at C. I'm going to do that right here underneath A. I think I have enough room. C says we're going to have 2 log base 2 of 5 plus log base 2 of 9 minus log base 2 of 75. Alright, so again, my first thing is I cannot have a coefficient in front. So I'm going to move that 2 over as the exponent. So we get log base 2 of 5 squared. And I can't do anything else with the others, so I'm just going to bring them down. Alright, and we know that log base 2, 5 squared we know is 25. So I'm not going to actually rewrite that. I'm just going to mark it out and put 25 above it. Now, when we combine addition and subtraction, remember, on their same level. So just work it from left to right. So I'm going to combine those two first. So remember, we're condensing, so we're going to write the word log down one time, 2, and when they're being added, we can combine them through multiplication. So this is going to be 25 times 9 minus the log base 2 of 75. And then just right above it here, I'm going to write that, was it 25 times 9, I believe is 225, instead of just rewriting another step, because as you can see, I'm towards the bottom of my paper here. And then we can combine these two logs because they're both log base 2. They're being subtracted, so we know we can combine them with division. So we're going to have log base 2 of the top first over the second. And then we can reduce that. And so we get log base 2 of 225 divided by 75 is 3. And so we get log base 2 of 3. Now remember, I said we need to check and see if we can work that out. So I'm going to come over here on the right, and so do a little area here. So we have log base 2 of 3, and it's log form set equal to y. So our base is 2, our x is 3, and our y is y. So b to the y equals x. Well, 2 and 3 will never go down to the same base. So I can't work that out to give me a nice, pretty integer. So therefore, we're going to leave it as log base 2 of 3. Okay, and then for D, I erased the top part here, and I'm just going to put it where I had A and B. D says we're going to have 1/3, and then it's got a square bracket, which is the same thing as a parenthesis. And we have the natural log of x plus the natural log, and then parentheses x plus 1, minus the natural log, and in parentheses we're going to have x squared plus 1, and then we're going to close our square bracket. Well, notice that 1/3 is out in front now, so just leave it there. Don't touch it till towards the end. So let's just work on what's inside. And remember, we're going to work from left to right. So we're going to combine our first two logs here. So I'm going to do this. I still have this 1/3, and I'm going to keep my square bracket for now. And we can combine them because they're being added right there. We're going to combine them with multiplication. So write down your natural log one time there. And then it's the first times the second. And then I still have minus the natural log of the x squared plus 1. Now inside parentheses, I just have a log minus a log. So we can combine them by division. So I'm going to keep the 1/3 still in front. I'm still going to have my square bracket there. So remember, we're combining, so you write your natural log once. And it's the first, which is the x times x plus 1, which you can distribute if you want to, over the second, which is the x squared plus 1 that was in parentheses. Now, since it's by itself on bottom, we can drop the parentheses if we want to. It doesn't matter. And then go ahead and close your bracket. Well, now notice we don't have so much as parentheses within parentheses, except for right there on top, which you can distribute if you want to. So I'm going to go ahead and drop the square brackets and just make them regular parentheses on the next step. So now what we've got here is we've got down to our single log. And so I'm going to take this 1/3 and now I'm going to move it to become its exponent. And so I'm going to write that right here next to it. So I have the natural log of, if you want to distribute the x there on top, you can. So I'm going to. So x squared plus x over x squared plus 1, and that's raised to the 1/3. Well, just like when it was raised to the 1/2, we said it was a square root, and since it's raised to the 1/3, that's going to be the cube root. So we're going to have the natural log of the cube root of x squared plus x over x squared plus 1. And there's our solution for D. Okay, so the next thing we're going to talk about is our change of base formula. And this is really so that we can either easily work it out algebraically, or we can put it in our calculator, which is base 10, or we have that natural log button, which is base E. And so we start out with log base B of x. And we can change this to any base that we want to using this formula. And so let's just say we want to go to a base, I don't know, let's say A. Why? We don't have a particular reason right now. We just want to change the base. And so what we're going to do is, this is the one time you will write the word log twice. So it's going to be log base A on top and it's log base A on bottom because that's the new base that we're going to. And then what I can do to remember which one goes where is, you see how that old base is written subscript, how it's down lower. So it's going to drop to be lower here. So it's log base A of B in our denominator. And how this x, doesn't matter what the value of them is, but it's written taller. It's higher. So it's going to go with what's on top up here. So I have log base A of x over log base B of B. Now, if I wanted to go to base 10, well, it's going to be equivalent because they all came from the same original problem. So I could rewrite this now as log base 10 on top and log base 10 on bottom. But remember, we don't have to actually write the 10 when it's base 10. That's our common log. And so again, x is taller, so it goes on top. The old base is subscript, it's down lower, it's going to go on bottom. And the same thing if I wanted to go to a natural log. If I wanted to go to base E. So if I want to go to base e, I'm going to write log base e on top and log base e on bottom, which remember that is my natural log. And again, the x would go on top and the old base goes on bottom. And all of these are equivalent and they're all equal to the log base b of x. So if I was to plug any of these combinations into the calculator, whether it's plug that in, this, or this, I'm going to get the same solution. All right, so let's check that out in example 4. So I'm going to erase this. If you need to, pause it. All right, so in example 4, it tells us to compute log base 5 of 13 by changing to common logarithms and natural logarithms. All right, so let's start out looking at the common log. And it told us we're going to change log base 5 of 13. All right, so if I want to do a common log, that's just log. So we're going to do log of what's written higher, so the 13, over log of the old base, which is the subscript written lower, so the 5. And so in your calculator, I actually want you to type in log of 13 divided by log of 5. Now be careful when you do this, because when you hit the log button, most of your calculator is going to open a parenthesis. And so after you type the 13, you have to close it, or it will give you the wrong answer. And then you'll do your divided by log, it's an open parenthesis, you put your 5, close it, and then hit enter. And if we do this correctly, we should get 1.594 approximately. All right, but it wanted us to also do this in natural logs. And so to use natural log, we're doing the same problem. So it's still going to be log base 5 of 13. But we want to use natural logs. And so we're going to have the natural log of the 13, because it's written taller, over the natural log of the old base, the subscript that's written lower, so it goes lower as the 5. And so in your calculator, you're going to type in the natural log of 13 divided by the natural log of 5. Same thing, when you hit natural log, it's going to open a parenthesis, so you're going to have to close it after the 13. And again, after the 5, hit enter, and it should give you approximately 1.594. Well, hopefully this makes sense to you that we got the same answer on both of these, because both of these came from the same exact problem. And so since they're the same problem, they should be the same answer. All right, so that's where I'm going to end this video. We've got exponential growth and decay we're going to talk about, and some other applications, and then we'll be done with 3.3.